The numbers I have listed up here are perfect square integers. 2 times 2, 3 times 3, 4 times 4, and so forth. And they go on forever. When we have them with a radical sign, this says what multiplied by itself would give me 81. And because 81 is in that list, we have that is simply 9. But when we get to something like square root of 28, I say what number times itself will give me 28. 28 would never be in that list. But here's what we do. We say, well, is there any factor of 28 that is in the list? And right away we say, sure, that's 4. So we write this as square root of 4 times the square root of 7. And this one, because 4 is a perfect square, I can write as 2, and I have the square root of 7. I have simplified this to saying it is 2 times the number that multiplied by itself will give me 7. Similarly, given square root of 75, there is no number that multiplied together by itself is going to give me 75. There's no integer. And so my best chance is to see if one of these is a factor of 75. Well, yes. 25 is a factor of 75, and 25 is a perfect square. So if I write this as square root of 25 times the square root of 3, I get 5 square roots of 3. I have simplified all 3 of these. This was easy because 81 is a perfect square. In those 2 cases, I had to find a factor that was a perfect square.